So this presentation is going to be common SQL tuning errors, and this is going to be presented by John Watson, who's an Oracle certified DB master. And what he's going to talk about for us is frequently seen errors in analysis and design. So talk a little bit about kind of how we develop things and kind of errors that come from that. Common programming mistakes, which is something that I know you never make, but it's just to help me out. Gathering all necessary statistics. So this is basically just trying to make sure that our stats are up to date, so we have all the information about our database. Recognizing suspicious structures and execution plans, so being able to identify things that don't look quite right, and then follow a solution discovery method. So John will make sure that given these potential errors that we can now spot and recognize, how do we solve them? Because if you don't know how to solve them, identifying the errors only half the battle. So without further ado, I'd like to go ahead and hand it over to John Watson on common SQL tuning errors and how to fix them.
Thank you very much, Tyson. Now, what I'm hoping to cover, I'm approaching this from the point of view of a database administrator rather than from a developer. And as a DBA, I see so many applications and I see the same issues in code again and again and again. I'm using the word issues, perhaps errors is a bit too strong. Things I see in code that I know are going to cause performance problems that are causing performance problems. And I want to go through just some of these. First point, you've got to validate your design. Look at your data structures. Think of third normal form. Now, I'm sure many of you were at college much more recently than I was. But at college, they teach you third normal form, fourth normal form. And there's probably someone in a university computer department somewhere developing 10th normal form. Now, you get some systems analyst straight out of college, he will normalize your data all the way. I know he will, because that's what I used to do. That is often not the best solution for decent performance. Over-normalized structures will not perform well. Under-normalized structures will not perform well. You have to understand your data, understand the queries that are going to be hitting it. If you only ever get to a child table through the parent table, you don't need to normalize it. You could denormalize that child table into the parent rows, and you'll improve performance. Under-normalization can help a lot if you do that, particularly in a data warehouse. But under-normalized structures will not perform too well either, particularly not for DML. You need to understand your data, understand the application that's going to hit it. What's more straightforward, though, is always making sure you have appropriate data types. And that's a problem I see over and over again. Problems caused by incorrect use of data types. Take a simple example like this. I'm working, by the way, in the Scott demonstration schema. So I've got my emp table with its 14 rows. Now, what I'll see so many times in software is code like this. Now, there is a person called Miller, who was hired on the 23rd of January, 1982. I can run this. Select star from emp where hire date equals 1982 0123. Back comes Mr. Miller. That code is horrific because what I'm doing is comparing a string with a date. That's logically impossible. You can't do that. SQL is a strongly typed language. So what Oracle has to do is typecast that string into a date before it can do the comparison. Looks good, it isn't. It's all cool, but what happens, for instance, I'm in Europe at the moment, what happens if I move to America? Set my territory to America, run that same query. Oh dear. Error. Well, an error is better than it could be. Depending on the nature of the problem, it could actually be giving me wrong results. If, for example, the 1st of May becomes the 5th of January, at least I'm getting an error in this case. So you've got to watch for it. What's the solution? You and your fellow programmers, we all have to be a bit more diligent in our coding. Rather than writing this, what we should have done was this. Select star from emp where hire date equals toDate of the string. With a format picture, specify a language. Always do that. That's one of the errors I see again and again and again. reliance on implicit typecasting. It isn't just that it can cause problems like that, it can cripple performance as well, because of the way Oracle will maybe not be able to use indexes and constraints to improve the performance of the query execution plan. So assess your data structures. Look at your key and indexing strategy. Index all your key columns. Many people forget to index foreign keys. Maybe they think they don't need an index on the key. Well, you may not need the index on the key. Oracle might. Take an example here. I'll log on as Scott in another session as well. And we'll see the sort of problem that can occur. In one session, I shall delete from emp where depth no equals 10. There go 3 rows. In another session, I shall delete from depth where depth no equals 40. Oh dear. That has happened because the foreign key column, depth no in the emp table, is not indexed. Row lock, or table lock in this case. That's going to cripple performance. And only when I terminate this transaction with a rollback or commit, then that wakes up. I'll roll that back as well. Solution, you must index your foreign key columns. So I'll do that. I'll create an index called FK on the foreign key column of the emp table. That's all I need to do. Now I can do the DML against emp, and I can do the DML against depth. Index your foreign key columns. You may not think you need the index, but Oracle may need the index. So, finally, constraints. Now, constraints are so important for performance. Constraints are much more than data integrity. Constraints tell Oracle about your data. I don't know how many times I've heard people saying, we disable constraints in the data warehouse. Why do you do that, I ask? Because they say the data's been validated. It's clean. We don't need the constraints. Wrong, wrong, wrong. You need the constraints for performance reasons, not just for cleaning your data. For example, I'll enable the auto trace facility in my session so we can see some execution plans. Let us say I run a query to count the number of employees in each department. Select depthno, count star from emp, group by depthno. Back come the answers. Department 30 has 6 employees, Department 10 has 5 employees. How did Oracle do it? Full table scan. Well, what if I make a change to the table? Describe emp. Now, I happen to know that every employee does have a department. So I'll tell Oracle that fact by declaring it not null. Now, when I run that same query, the cost has dropped to 1, whereas previously it was 4, because we are now doing an index full scan. And that's only happened because I declared the column not null. So anything about your data, tell Oracle about it. The more constraints you have, the better. And this is even before you've begun to tune the SQL. These are just general principles you should be applying to all tables. Okay. Move on. Now, this is something that you could discuss for a long, long time, making your code readable. I am in favor of using ANSI joint syntax. Some people aren't. It's one of these points that's debatable, right? But I strongly believe it's less prone to error. Please format your code. Case sensitivity, uppercase for keywords or whatever, for identifiers. Think of suitable indentation. Use meaningful table aliases. I was looking at some code only last week, which was joining about 4 tables. And the tables were aliased as A, B, C, D. Well, great. You look at the code lower down and you haven't a clue what's going on. Use meaningful table aliases. Include comments. Yes, I know you can say that, well, if you can't understand my code, you shouldn't be trying to look at it. Well, that's not really the best attitude. Include comments. I find even with my own code, I often can't understand it 6 months later. So make your code readable. Having got through those 2 stages, validate the design, make the code readable. You've now got your code into a state where it can be tuned.